In this tutorial, we'll be talking about particle systems. Particle systems have many applications. For example, they are used to draw the smoke coming from a chimney and to simulate the dust on a vehicle's tires, to depict the dirt that is churned up when tilling the soil, or to create the wood chips from the chainsaw. In the following, we'll look at how particle systems are created so as to enable optimal customization of these systems to the respective application. We'll do this in two steps. Firstly, customize the basic shape for the exit field of the particles. Secondly, set the attributes of the particles, especially the physical attributes and the number of particles emitted. Before we can get started, we need to download sample files. As always, they are available via the file link beneath the video player. Once the download has finished, we'll copy the archive to our desktop and extract it. Now let's open the file Forestry Chips i3D to get an idea of what's involved. We'll open the first particle system and select the object beneath it, Emit Shape. This object specifies the shape from which the particles are emitted. Via the menu Create Light, we'll create a source of light to see the scene better. Once we are satisfied with our settings, however, we need to remove this source of light again, as otherwise it will be displayed when the particle system is active in the game. First, we need to get the new shape into the i3D file by going to the menu and clicking File, Import. Let's select the file flat_2x2 i3D and click on Open. Now we have the new shape in the i3D file, and we'll save the scene by going to the menu and clicking File, Save. This action is confirmed in the console window. Next, we'll open the file Forestry Chips i3D in Notepad++. The last entry in the scene container is for the newly imported shape. We'll now copy this line into the container for the particle editing panel. All we need to do here is copy the value for node ID and enter it in the particle editing panel's entry at Emitter Shape Node ID. When we've done this, we save the file with Notepad++ and go back to the Giants editor. Here we click on the icon for reloading the i3D file. When we press play, we can see the wood chips being emitted from the new shape. The last step is necessary to make the shape invisible. To do so, we click on the Shape tab and activate the checkbox Non-renderable there. Naturally, we can delete the old shape now. Afterwards, we should save the file in the Giants editor. Next, we're going to look at the attributes of particle systems. First, we open the particle editing window. We can find it in the menu in Window, Particle Editing. Now we'll work our way through just about the entire list of attributes from top to bottom. The attributes are divided into three subsections: Simulation, Spawn, and Rendering. We'll start with the Simulation subsection. First, here we have the maximum number of particles that may be visible at a given time. This value only affects the present particle system. In this respect, we mustn't make this value too high, as otherwise we may experience performance issues in the game if several particle systems are active. Next, we have the lifespan of particles. With this, we basically determine how long the individual particle remains visible. The values scale x and scale y allow us to determine the size of the particles. We can also enlarge or shrink the particles as they age, which is configured with the values scale x gain and scale y gain. Next, we have three options to configure particle rotation. The first is the checkbox Rand Init Angle, which allows us to assign the particles a random rotation when they initialize. The second is two sliders that let us configure the maximum spin of the particles during their flight of lifespan. This basically sets the rotation speed of the particles. The fields for gravity are essential for a particle system because they have a substantial effect on the trajectories of particles. With these three values, we configure the accelerating forces that affect every single particle. Now we'll look at the next subsection, spawn. This subsection comprises settings for the initial movement of particles right after they are created. First, we need to adjust the emit rate, which specifies how many particles are created per unit of time. It's recommended to try and keep the emit rate as low as possible, meaning generate as few particles as possible, because this keeps down demands on the CPU and graphics card. The next value, speed, indicates the speed of the particles when created. There are some cases where particles shouldn't all have the same speed. There's another slider for this called speed random. This lets you configure how substantially individual particles should differ in terms of their speed. The last two items in the subsection spawn influence the direction in which particles are emitted. For example, it enables the particle's trajectory to be changed from a beam to a sort of fan. The value normal speed specifies how fast the particles are propelled or start from the exit field in the direction of the normal ones. We can also assign a negative value to the attribute normal speed, which makes the particle travel in the opposite direction. The value tangent speed specifies the degree to which particles are dispersed. Now let's look at the last subsection, rendering. First, using the slider blend factor, we can configure how transparent the particles will be drawn. The values blend in time and blend out time let us configure the time period the particles should be visible, in other words, how quickly they are shown and hidden. Down here, we have the parameters texture atlas size and texture atlas size Y, which specifies how many subdivisions the utilized texture possesses. These values often have the setting 1 because that's sufficient for many applications. In our case, however, this value is set to 4, that is, each new particle is created at one of these 4 points, generating a higher level of visual variance. The final aspect to discuss in this tutorial is the checkbox Z sorting. When activated, the particles are sorted according to depth, but this option can be left deactivated as it is only helpful in very rare cases and substantially increases load. We'll end off with a tip on how to adapt the behavior of a particle system in the game. There are plenty of situations where the particles are supposed to follow a certain route along the vehicle instead of being deflected from their trajectory, as would be physically accurate. You can set a user attribute to achieve this effect. We'll create a Boolean user attribute with the name useWorldSpace in the particle systems node. If we set it to true, the particles will obey physical acceleration in the game later on. In contrast, if we set it to false, the particles will only move based on the data in the particle system and will not be diverted by the game's global gravitation.